قَرٌّ وَمَتَاعٌ إِلَىٰ حِينٍ فَتَلَقَّىٰ آدَمُ مِن رَّبِّهِ كَلِمَاتٍ فَتَابَ عَلَيْهِ ۚ إِنَّهُ هُوَ التَّوَّابُ الرَّحِيمُ. قُلْنَا اهْبِطُوا مِنْهَا جَمِيعًا فَإِمَّا يَأْتِيَنَّكُم مِّنِّي هُدًى فَمَن تَبِعَ هُدَايَ فَلَا خَوْفٌ عَلَيْهِمْ وَلَا هُمْ يَحْزَنُونَ. وَالَّذِينَ كَفَرُوا وَكَذَّبُوا بِآيَاتِنَا أُولَٰئِكَ أَصْحَابُ النَّارِ ۖ هُمْ فِيهَا خَالِدُونَ. يَا بَنِي إِسْرَائِيلَ اذْكُرُوا نِعْمَتِيَ الَّتِي أَنْعَمْتُ عَلَيْكُمْ
We have almost 1,700 people a day dying from cancer in this country. That is about 70 people an hour. If you have type 2 diabetes and you're obese, you're at super high risk for cancer. Only about 50% of the women that have that gene will actually go on to develop some sort of a tumor. Your very healthcare providers are almost clueless. We specifically kill tumor cells by taking away the only fuels that they use to survive. It's an elegant, a beautiful, non-toxic way to get rid of cancer.
Hey SB fam, welcome back to the channel. It's me, Bella the Steak and Butter Gal. I hope you all are having an amazing day, and as always, I'd love to know how you are doing. Drop an update down below in the comments. Today, I will be inviting on Professor Thomas Seyfried to speak on his latest findings and full protocol on how to prevent, treat, and fight cancer. Professor Thomas Seyfried will be a guest speaker in the SBG community. If you would like to submit your questions for Professor Thomas Seyfried, make sure you join the next challenge by going to the URL shown on the screen, sbgmeetup.com, or check out the links down below in the description box. Welcome, Professor Seyfried. Do introduce yourself.
Hi, I'm Tom Seyfried here, professor at Boston College, and it's nice to be here and meet you folks today.
What are the biggest lies we've been told about cancer by doctors and the medical community at large?
Most of the physicians that talk to people tell them what they think they know. They don't realize that it's a metabolic disease. It's not a genetic disease. So, and I don't think they know that. They haven't been trained. The field, majority of people in the oncology field are not aware of that. And it becomes clear when they discuss this with their cancer patients. So if a person doesn't really know something, that would be lack of knowledge, not related to actually lying like these politicians do. Okay, so we know that. The great tragedy in my mind is the therapies that are offered to cancer patients are based on the conventional knowledge that cancer is a genetic disease. When you look at radiation and poisonous chemicals, we all know, everyone, even the oncologists, know that that's not good. And there, by the grace of God, you might survive these very, very toxic treatments. Those toxic treatments were supposed to have been eliminated with the promise of the genomic investment in cancer. We've spent $100 billion on the Cancer Genome Project. The promise of the genome investment has not been coming, and it won't come because cancer is not a genetic disease. So we have to continue to rely on very toxic treatments for cancer because the promise of the new precision medicines and personalized therapies have not been realized. We have almost 1,700 people a day dying from cancer in this country. That is about 70 people an hour. So in this discussion that we have, 70 people will be dead from cancer. Okay. And that just came out. We have cancer statistics just came out the other day, 2024 cancer statistics. And what they said is we've reduced cancer deaths by 30% since 1991. And that's because the anti-smoking campaign was started in 1991. So had we all continued to smoke, we would have 30% more cancer deaths than we have right now. So this doesn't speak to new therapies for people that already have cancer. It's the prevention. So if you stop smoking, you'll prevent a lot of different kinds of cancers. And people look to that as if we're making major advances in managing cancer. And the fact is we're not. It's an abysmal disaster. It's probably goes down as one of the greatest tragedies in the history of medicine. And it's not, and nobody's lying to anybody. They just put all their eggs in a singular basket, and that basket happens to have a huge hole in it. And we're not getting the benefits of all the billions of dollars that we have invested in this disorder. And that means, so the theory under which the disease is viewed and managed is incorrect. It's a metabolic disorder. And once you realize that, we'll be able to drop the death rates by 50% in 5 years. But you have to overturn a monstrously powerful system and paradigm. And that's not going to happen anytime soon.
Does that mean it comes from the parents? Is that how we develop cancer?
You have two kinds. You have somatic mutations and you have germline mutations. So germline mutations are those that are passed down within families. And you hear about the BRCA1 and you hear Li-Fraumeni and you hear a variety of other of these so-called, these are inherited risk factors. They are secondary risk factors. The primary risk factor is damage to the ability of the cell to generate energy through oxygen. So when you see these mutations in families, like the BRCA1 that you hear an awful lot about because of Angelina Jolie and others having breasts and ovaries and all this kind of stuff removed as a prophylactic because they carry the gene. But the issue is that only about 50% of the women that have that gene will actually go on to develop some sort of a tumor. 50% of them will not. And the answer is we're not really clear about that, but we know that every one of the women that did develop a breast tumor or an ovarian tumor or whatever that carried the gene, we always find that the cells are fermenting. They're using energy without oxygen. So we know that's the common link for all these different cancers, whether it occurs sporadically or through the germline. So when we hear about cancer as a genetic disease, that comes from the theory that somatic mutations cause dysregulated cell growth. So you have to say to yourself, what is this? What is cancer? It's cell division out of control, dysregulated cell growth. What causes that? And the answer according to the National Cancer Institute, and it's gene mutations in a variety of different targeted genes. But we and others have shown that those mutations are not the cause, they're the effect of damaged energy metabolism. So the mutations are effects, they're not the cause. So if you're constantly chasing effects, the outcome is never going to be optimal. And when you have, we're targeting this gene and that gene, all of those are downstream effects, they're not the cause. So this is why the field is locked into this perpetual problem where you hear all this, but cancer is out of control. When you have 70 people an hour dying from a disease, this is an out of control situation. And it's going to stay out of control as long as the field continues to put energy into all these gene mutations. And then you have the immunotherapies, which you hear about, Keytruda, Opdivo. That's all based on the somatic mutation theory of cancer. And if the theory underlying the disorder is incorrect, those drugs are never going to be optimal in managing and reducing the death rate. That's what I want to know. Can you reduce from 1,700 people a day to 800 people a day? That would be a huge advance. If you did that in 5 years, you know you're on the right track. So, right now, the system, it does not acknowledge that. They have no clue. Not all of them, of course, but most oncologists, when you tell them it's a metabolic disorder and you can manage it using diet lifestyle issues, they say there's no evidence to support that. And the evidence, they don't read the evidence. Well, it's one thing, and it's another thing. If you don't read the research material and understand it, then you remain ignorant of the information. And there's no way. And you're not trained in medical school to know this. You're trained that cancer is a genetic disease. You go to the National Cancer Institute website, everything's cancer is a genetic disease. And you feel like, well, there's nothing I can do about it. I've inherited these genes and it's out of my control. That's wrong. Everything is, you have a lot of control over this disorder. It's just that you've been made to give an opinion that's not supported by the new science.
Do you think money, industry, and economic markets influence the way we perceive cancer treatment and cancer as a whole?
I think there's a lot to be said for that. We all know about physical toxicity. The reason why people fear cancer is because they don't want to have to lose their hair and vomit and die and all these. We call those physical and mental toxicities. But we also have a new form of toxicity called financial toxicity. So you can't believe how many folks in this country that aren't well off are more or less living paycheck to paycheck, and then they get hit with a cancer bill for $30,000. It causes families to disintegrate. People commit suicide. It's a tragedy of monumental proportions, and it's called financial toxicity, and it's just as deadly as some of the physical toxicities that we're associated with. So why should drugs that don't work for so many people? You should charge people only after the treatment works. You should never pay up front for any of this stuff. If it works, then you should pay. You should have some sort of a payment system The longer you stay alive, the more you pay. You shouldn't pay $30,000 and then in a year you're dead. It doesn't make any sense. So we need to change the way we view how successful are the treatments. You go to the physician, he charges you a surgical procedure. Okay, some of this is expected, but a lot to be charged for drugs that cause you to have your hair fall out, your gut destroyed, and all these other horrible things. Why are you paying all this money for something that's causing you harm? Yes, and there's a huge industry associated. The cancer industry is known to be one of the wealthiest. I mean, they make billions of dollars on these drugs. But I don't think people would mind it too much if the drugs actually worked. As I said, we got 70 people dying this hour that we're speaking, and many of them have taken some of these drugs. So, and they fail one after another. And not only that, if you do happen to survive, and believe me, there are millions of cancer survivors who have survived the so-called standard of care, but a good number of those folks now suffer from digestive, hormonal, mental, all kinds of physical ailments that actually reduce their survival on the planet. And you die from other things. Oh, you were cured of your cancer, but now you die from heart disease, and you die from bone density issues. You die from all these other things as a secondary effect of being treated with very, very toxic approaches. So, and that's what people don't want. They would like to be treated for their disorder with something that's not going to be harmful, that actually makes them their outcome better. And this is what we published, this Press Pulse, where we gradually degrade the tumor slowly as we enhance the health and vitality of the body. There should be no hair loss. Anytime you see a cancer patient that's bald, why that person is bald? You're trying to kill the tumor cells, not the hair follicles.
Right.
I mean, let's be honest. I mean, you get off-target effects. You shouldn't have off-target. We specifically kill tumor cells by taking away the only fuels that they use to survive, which is glucose and glutamine. And the people get healthy. As you're degrading the tumor, you're also getting rid of a lot of other collateral problems like diabetes, high blood pressure, hypertension. A lot of these things go away along with the cancer. The problem right now is what I've just shared with you is not known or understood by the majority of healthcare providers in this country. That's the problem. There's a lack of information dissemination of what I said. The science is clear. The problem is the word is not out there, and people then run off to the oncologists. And when you ask them about metabolic therapy, metabolic oncology, they never heard of it. So your very healthcare providers are almost clueless as to the biology of the disorder they're treating. If they don't know that it's a metabolic disorder, that's a tragedy. And the consequences are 1,700 people a day dying from this disease.
So you mentioned diet and lifestyle. Can you elaborate on what specifically regarding diet and lifestyle could be detrimental?
There's a whole slew of things. Minimal exercise. The obesity epidemic has now replaced smoking as one of the highest risk factors. We have forever chemicals in the environment. We have very little exercise. All of this comes together, and some folks could get type 2 diabetes. Some folks could get cancer. Some folks could get dementia. Some folks could get macular degeneration. There's a whole series of chronic diseases associated with our diet and lifestyle. And if you just measure your blood work, you can see that right off the bat. If you have type 2 diabetes and you're obese, you're at super high risk for cancer. This should not be a mystery to anybody. So in fact, as I said, we've managed a lot with the smoking reduction, but now we're creeping up again with the obesity epidemic. So clearly smoking, if you remember, years ago, smoking was common. 50% of the people in the society were smokers. We'd go to movie houses and there would be smoke in the movie houses and restaurants. But now we're cardiovascular disease a little bit. But now we're replacing smoking with our also a diet and lifestyle issue. So it's just who we are as a population, as a species, that put us at risk.
So a lot of the viewers who are watching right now, they are on a carnivore diet lifestyle. So they're eating animal protein, animal fats, zero carbs. What are your thoughts on a zero carb way of eating?
Well, we developed the glucose ketone index calculator, which allows anybody, whatever kind of a diet you want, Mediterranean diet, pescatarian diet, Paleolithic diet, all of these different kinds of diets, carnivore diets. You look at your glucose ketone index, and that tells you what level of nutritional ketosis that you're in. So we get people into nutritional ketosis, and then we attack the tumor cells using off-label, off-target drugs. That's another thing. The therapies that we use, these drugs are cheap. You can't make any money on them. You can't make money on any of the stuff that I'm talking about. So, and that's the great tragedy. And that's why it can never happen, because nobody can figure out how to make a buck on it. But we know it works, and it works really, really well. But, there is a requirement here, and it's called personal discipline. Yes. You have to have some level of discipline to get your glucose ketone index, yes, which could take on a very low carbohydrate diet, and you can use any kind of a low carb diet you'd like. It might take 14 days to get into a GKI. And then we jump for a few days into water only fasting. And then we hit them with the drugs that actually hammer these tumor cells out of existence. Once you put the body in this new metabolic state, these tumor cells become extremely vulnerable to very small doses of various whole array of different kinds of drugs that go after the glucose and glutamine. It's an elegant, beautiful, non-toxic way to get rid of cancer. But it does require the patient to participate in the outcome. You're not just going to sit there and have some part of your body irradiated or chug down some sort of a toxic poison. This is a patient participatory activity. And I understand there are some people who choose to go standard of care. They don't want to take charge. And there'll always be an avenue for those guys. If you want to be irradiated and this surgical mutilation, removing breasts, it was already shown years ago that there's no redeeming survival advantage from a lumpectomy versus a mastectomy. And yet the evidence is published, yet the poor women are being mutilated. There's so many ways to go about managing this disease in ways which are different from what's going on in most of the clinics today.
Could you break down for us what a GKI measures?
Glucose is measured in milligrams per deciliter, and ketones are measured in millimolar. So you have to convert the milligram per deciliter into millimolar. And what you simply do is divide that number by 18, approximately 18.03 or something. Then you convert your glucose, so the same units. You're dividing glucose in millimolar by ketones or beta hydroxybutyrate in millimolar. So then you can get a ratio in millimolar units. So what Dorian said, the simple process of dividing your blood glucose by 18 is too complicated for 90% of the people in this country, which is a real embarrassment. But he said, we have to make it easy. So just get your blood sugar and push the button, boom, on the meter, and it gives you the ratio right there. You don't have to get a paper and pen or use your brain to do the ratio calculation.
Okay.
So it just, people know, oh, look at my GKI. So they're all excited about it, and it's just a very simple ratio. And, we're not 100% sure that ratio will always be an accurate indicator of your present status, because there can be some really strange metabolic things happening in a person's body. So there's always other measures that should be looked at along with the GKI. It's not to be looked at alone as a simple entity. You have to look at the blood work. You have to look at all the metabolites that are also in association with that. And you start to see the overall physiology move closer and closer to what would be considered ideal health. Mm-hmm. At the same time, the person has a tumor, and yet the body is in ideal health. And the tumor now is going to be absolutely, you have a chance to really rip into those cells and kill them with various dosages and timing of these drugs. This is the future. This is the management of cancer if we want to stay alive from this disorder.
What are your top recommendations for food and lifestyle habits to lower cancer risk?
It's hard. As I said, get your GKI down. Any food that brings it into a low GKI. Okay. So you just take the meter, the Keto Mojo or whatever, and measure your GKI. And it'll tell you right away what you can and cannot eat. It'll tell you right away the best or the worst food to eat, because you'll know your body is telling you. And that could differ from one person to the next. Okay. So they're always saying, oh, what food? I don't know. Eat a big donut and see what it does to your GKI. If it makes it go through the roof, don't eat the donut. It's not that mysterious. If you want to, gnaw on a big steak and see how that affects your GKI. Some people may respond better to a vegetarian diet than a carnivore diet. I don't know. It's everybody's in an individual. But the GKI doesn't lie.
Besides tracking GKI numbers, do you also recommend tracking fasting insulin numbers and insulin in general?
Well, I did all those studies in the mice. People have done it in humans as well. When you don't eat food and carbohydrates, insulin naturally goes down. Carbohydrates, the trigger for having insulin-like growth factor, and all these other things. So when you don't eat for like a week or so, you become very insulin sensitive. And that's Averta Health with Jeff Olick and some of the other individuals there cure type 2 diabetes, just doing water-only fasting and calorie-restricted ketogenic or low carbohydrate diets. You can do it with all these diets, but it's not easy. I don't want to make it look like this is a panacea. Oh yeah, just go out and don't eat carbs. Your brain is addicted to carbs. Some people will try to not eat for 3 or 4 days. You start shaking. I mean, it's like, as I said, it's not easy. That's why we try to gradually move people from a carbohydrate diet to a low carbohydrate diet and see if your GKI will definitely go down. Whether it hits the zone of 2.0 or below, I can't be sure. Because I've had a lot of people say, oh, I've been doing 0 carb for 3 weeks and I still have a GKI of 10. Well, I said, don't eat any food, just drink water and see what happens. And the next thing you know, all of a sudden it's down there. Now, there's always somebody. Now, the other thing with cancer, it's very hard sometimes to get into these low GKI zones because the treatments that you take, like radiation and chemo and some of this, puts a huge stress. The body knows it's under tremendous stress and it releases corticosteroids, which elevate blood sugar. So you're battling, you're trying to stay massively healthy at the same time you're being abused. So people need to know that. And that's why I have many cancer people email me and says, I'm just struggling to get in there, but they're also at the same time in very toxic treatments. And that can oftentimes make it more difficult to get into low GKI values. As opposed to someone who say, oh, I was just diagnosed with cancer. I never knew I had it. I felt pretty good other than they found something and now they want me to. In my mind, that's the time you go on the metabolic approach, get your GKI really, really low, and then see what the non-invasive scans start to show. And if you start to see the scans and the intensity going down, so the cancer cells are now being compromised by the whole change in the physiology of the body. And then again, if you can shrink it down so it's really small, yes, a surgical debulking can potentially cure you, or even a shot of radiation on a small area without disturbing too much.
Krijg tot 50% korting tijdens de Belliani zomersale.
Groot assortiment, aantrekkelijke prijzen, Belliani.nl.
Could possibly cure you. There's a lot of strategies that we can get into the zone where we can bring the beast down to a manageable level, and then you can possibly use an immunotherapy to kill off the few surviving cancer cells that were resistant to the metabolic approach. So there's so many new strategies for managing cancer to keep people a lot healthier and with a higher quality of life. This will come. This is what I just told you is the future. It's just that it's not known by a lot of people. That's all.
So you clearly stated that sugar feeds the cancer cell. Could you explain more about the difference between glucose and glutamine and how these two affect cancer growth?
The cancer cannot live without glucose and glutamine. There's only two fuels. We've interrogated the cancer cell. Here's what we do. We take these tumor cells and we put them in saline, which is a salt solution. No fuel, nothing. and then we see how long it takes them to completely die. Without fuel, remember, without energy, nothing can survive. Energy is everything. The whole cancer issue is energy, energy, energy. So how do you know what a cancer cell needs to survive? You grow it in salt, and then it dies. It dies. And then we add stuff back, one at a time. And we find that things, and all of a sudden, you add glucose back, boom, this thing starts growing again, even in the salt. Okay, so then we add each amino acid back. And we found out that the amino acid glutamine, together with the sugar glucose, is the most robust driver of dysregulated cell growth. There are other amino acids. They can play a minor kind of a role, but nothing like glutamine. Now, targeting glutamine, you can't do it very effectively with diet. Vigorous exercise can lower glutamine levels, but you need drugs. And in our mind, those drugs are parasite medications, okay? Because the parasites and the sugar, the parasite and the cancer cell use common metabolic pathways, if you can believe it. Yeah, so that's why some of these so you bring the patient down into this new super healthy state, and you go after the glutamine and the glucose simultaneous. Unbelievable. You probably can't appreciate how powerful what I just said to you is until you actually see it yourself. And the problem is most people don't see it, and they think, oh, what food can I eat for glutamine? No. You got to use it. You can get it down, but you can't really get it to below this like threshold. Once you get it below that threshold, don't forget, these tumor cells have to have a lot of fermentable fuel. They're not energy efficient like our normal cells. Our normal cells can live on the most minuscule amount of nutrient in the environment and still be healthy. The tumor cell has to have a buttload of glucose and glutamine. Once you go below a certain threshold of levels, these tumor cells, they up and die because they ran out of energy. So that's the whole strategy. Simultaneously cutting off the two fuels that drive the dysregulated growth, while at the same time transitioning the body to ketones, which we evolved to burn in times of fasting. Okay, tumor cells can't use fatty acids in ketone bodies.
Yes.
So you starve them. They're marginalized. They're weak. They have all these genetic mutations. Sure, they have a lot of mutations. That prevents them from adaptability. So unless you understand evolutionary biology like we do, you might have difficulty understanding how we put all the parts of the puzzle together to get the outcome. So that's another thing. We study evolutionary biology because that holds the key to this whole cancer problem. So if you really want to know how to do all this, you got to know how to connect all of the dots, understanding the origin of species on the planet, and understanding how these cancer cells have deviated from the way we understand biology and biochemistry to work. And once you understand that, these cancer cells are sitting ducks for all kinds of attack that's not harmful to the body. But what I shared with you right now is just simply not known or understood, and even sometimes resisted by the field. So I'm always saying, prove me wrong. Show me a cancer cell that can live without glucose and glutamine. I've been throwing that out to the field for a long. Nobody shows me because they don't exist.
Right.
When you say foods with glucose, does it matter what form that glucose is in? So I think about fruits versus a donut. Is there a difference at the end of the day when trying to prevent and fight cancer?
Whatever you're eating must be nutritionally balanced. And what I mean by that, you cannot be deprived of macro and micronutrients in whatever you're eating to keep your normal cells healthy. But whatever that is, again, it comes back to measure your glucose ketone index, and then you'll know. Now, fruits are interesting because when I worked in the epilepsy field for years and years, we would manage children on metabolic therapy, ketogenic diets for months, and then they would take a bite of some sweet thing like an orange or an apple or orange juice. And they, within a very short period of time, would explode into an epileptic seizure. So it was quite clear how fast we could remove the suppressive effects and have the outcome. With cancer, we don't see that. But when we were working with epilepsy, we realized that grapefruits had an opportunity to maintain good vitamin C but not jack sugar up too high. So yes, again, it's the kind of fruit and the amount of fruit and all of these things that play an important role. And again, you can't see a few extra tumor cells growing like you can see a full-blown epileptic seizure. So we were able to see how powerful constant management of blood sugars in children with epilepsy, how important that was for maintaining resistance to seizures. The mechanism by which that happens has not been as clearly defined as the mechanism by which killing cancer cells works. This is an amazing thing. Many of my colleagues in the epilepsy field are still working very hard to try to figure out how these diets, ketogenic diets and things, and modified Atkins diets and all these can manage epileptic seizures. But for cancer, we know very clearly how it works.
Professor Thomas Seyfried will be a guest speaker in the SBG community. If you would like to submit your questions for Professor Thomas Seyfried, make sure you join the next challenge by going to the URL shown on the screen, sbgmeetup.com, or check out the links down below in the description box.
Now, you mentioned about vitamin C. What's the correlation there with cancer on the vitamin C, especially?
IV vitamin C leads to oxidative stress in cancer cells. So again, you're causing oxidative stress. But the issue, of course, is if you have fermentable fuels in the cancer microenvironment, which is glucose and glutamine, they have a very powerful antioxidant capability. Okay, so glutathione and superoxide dismutase and all of these are powerful antioxidant systems in the cancer cell controlled by the fermentation metabolism. So as you degrade the fermentation, which is the removal of the fermentable fuels, the tumor cell will naturally become more vulnerable to oxidative stress, whether it's through hyperbaric oxygen, IV vitamin C, or other kinds of approaches that would increase oxidative stress in the cancer cell, but not in the normal. If the normal cell is burning ketones, it's very resistant to oxidative stress because it's a very different energy metabolism for burning ketones in normal cells, and the cancer cell can't access that kind of metabolism. They're locked into this ancient pathway of energy.
I think about that when in a normal water fast, your healthy cells, your normal cells seem to be actually getting stronger. Is that accurate?
Yes, and that's because they're burning ketone bodies. Yeah. So we evolved, but the mechanism for that was worked out by my late good colleague and friend Richard Veitch at the NIH. It's a very complicated biochemistry, and it has to do with delta G prime ATP hydrolysis, and they're delivering more protons for the proton motor. I can go down into the depths.
Better energy, right? Can we say ATP, better energy?
Yeah, it's actually 25 to 26% more energy efficient when you burn ketones than when you burn glucose. And fewer oxygen-free radicals are produced as well. So it's an anti-aging kind of a thing. So, but the normal cells can do that. The tumor cells cannot do that. So they're compromised, they're restricted, they're marginalized. Because of all the mutations that they have, all these mutations. Nobody's arguing with the mutations. They're downstream effects that block the flexibility of those cells. They're locked into fermentate. They're no longer flexible. So once you move the whole body into these new metabolic zones, these tumor cells get hammered.
What tests and exams should people take to reliably track cancer risk?
Well, I think, again, your GKI. It's hard. Well, let me put it this way. It's very, very hard. If all cancers or the majority of cancers are due to damage to the organelle, the mitochondria, that make energy through oxidative phosphorylation, in order to get cancer, that organelle must be damaged. So if you can keep that organelle healthy, it's very unlikely you're going to get cancer. And this was seen in our Aboriginal folks, the Inuit, African tribes, rainforest people, Aboriginals from Australia. If these guys live according to their natural ways, cancer is extremely rare, okay? So they're not eating fast foods on every corner. They're not sitting in front of their computer screens. Whatever they're doing, they're getting a sufficient amount of exercise, and they're eating foods that enhance the health and vitality of their normal cells, and they don't get cancer. And or cancer is extremely rare, okay? Not 1,700 people a day dying like we have in this country. And in China, it's like 8,000 a day because they have a bigger population. So in fact, in China, the cancer has now replaced heart disease, cardiovascular disease, as the number one killer. So once people know how you get cancer, how it starts, how it progresses, and what you need to do to prevent it, then you can drop this whole thing. But then again, you have to modify diet and lifestyle.
The question also that I have that I don't seem to understand. So all of us kind of build a certain amount of cancer cells in our body, supposedly. And from what I heard is that our body can actually set these cells to have a kill switch. Now, is that legitimate?
The kill switch, if they can't get energy from fermentation, they're going to die. So
that's what that is.
So I mean, that's the bottom line. Without energy, they're going to die. They can't respire. They can respire a little bit, which I mean they can get small amounts of energy from oxygen, but it's not sufficient by itself to keep them alive. They have to have the fermentation machine going at the same time, which is driven by glucose and glutamine. Okay, so that's another thing. When you take away the fermentation, the two fuels that drive this ancient non-oxygen energy metabolism, and then you give them oxygen, you create tremendous oxidative stress in the tumor cell because they're buffering against oxidative stress is the fermentation metabolism. So if you lower the fermentation metabolism and put them in like hyperbaric oxygen or something like this, you greatly increase and explode the tumor cells. But you got to get rid of their protective fermentation metabolism first. That's why we use hyperbaric oxygen only when the patient is in a low glucose ketone index. Now the tumor cells are going to be massively vulnerable to hyperbaric oxygen, possibly vitamin C, possibly a lot of these, IV vitamin C, anything that will increase oxidative stress. Because don't forget, that's why radiation kills tumor cells, oxidative stress. But radiation does a lot of collateral damage. Right. So you want to do the same thing radiation does, except making the microenvironment super healthy around the tumor cell. Get rid of the acidity. That's another thing. These tumors are very acidic because the waste products of fermentation acidify the microenvironment. So again, if I take away the fermentation fuels, the acidity goes away. They become vulnerable to oxidative stress. You're breathing, right? I'm breathing. All the folks this is called oxidative respiration. We're using oxygen to get energy in the mitochondria of the cell. Okay, the cancer cells don't use oxygen to get energy. They do fermentation, totally different. It's energy without oxygen. You have to realize that all the organisms on our planet, 2.4, 2.5 billion years ago, were all fermenters. There was no oxygen in the atmosphere, but we have fossils of all these cells that were alive. They're all fermenters. So they're using ancient pathways of energy metabolism, not requiring oxygen, and that's called fermentation. Cancer cells are locked into fermentation for energy. They don't use oxygen or very little oxygen. So we know how to kill them because they have fallen back as the ancestral cells that existed on the planet all these billions of years ago. So that's why when I'm saying evolution, you got to know how organisms developed and evolved on this planet. And then you know what the cancer cell is doing differently. And then you say, how is it living? What is it doing? It's doing the same thing cells did 2.5 billion years ago. And what happened in that time, when the fermentable fuels in the environment were used up, these cells would die. And we're seeing the same thing happen to the cancer cell. When you take away their fermentable fuels, the cells will die. So it's how effective you are, how effective the strategy is in depriving the tumor cells of their fermentable fuels, which are predominantly glucose and glutamine.
If you're new to the carnivore diet or a low-carb lifestyle and you're struggling with symptoms like headache, muscle cramping, lower energy in the gym, this could be due to an electrolyte imbalance. It could be helpful to use a high-quality electrolyte supplement temporarily. This is the one that I always recommend by Element, specifically this blue teal colored box labeled raw unflavored. You can just take it on the go wherever you go, rip one open, pour it in your beverage, mix it up, drink it down, and you're good to go. You all can get a free sample pack with any purchase, and it does include the raw unflavored one, as long as you go to the URL shown on the screen, drinklmnt.com/SBGAL. I've also linked them down below.
If somebody was to do a seasonal fast, water fast for prevention, I know I hear you talking about this GKI, that's going to be an important part of this, and this can take 14 days. You could take a couple days. Do you have any thoughts about doing something like as a preventative?
Of course, prevention. But from my understanding, we have an obesity epidemic. How many people really care about prevention?
Yeah.
Let's be honest, right? I mean, if people were really interested in not getting cancer, we would not have an obesity epidemic, especially among little kids. We're putting those little kids at terrible risk for all kinds of chronic diseases. It's a tragedy, and you can see it happening right before your eyes. All of those kids, they're already putting themselves at tremendous risk for not only cancer, but diabetes, type 2 diabetes, cancer, cardiovascular disease, dementia. All of this stuff is related to the same problem. And I don't think the word is out that this is a tragedy. And now I'm seeing, and now this paper is published, that cancer is now striking younger and younger people all the time. Wow. In their late 20s, 30s, and early 40s. And that's because of the diet and the lifestyle that we're in. It's not a genetic predisposition. It's the diet and lifestyle that we are currently in. And once you know that, then you are in a position to do something about it. Now, whether you want to do anything about it, that's up to the individual. But at least you know that if you stay on that path, your probability of long-term survival on the planet is reduced.
Where do you recommend viewers go to find reliable research on cancer and nutrition?
You know, that's a big hodgepodge. You can read all these different papers about eat this, don't eat that, don't eat that. Just look at your glucose ketone index. You know, I built that. My colleagues, my student Josh Meidenbauer and Purna Mukherjee and myself, we built that for the cancer, especially glioblastoma patient. But now on the web, I'm seeing more and more health gurus and all these weightlifters and bodybuilders and just super healthy guys, all using the GKI to see how healthy they can become. So I didn't make it for that, but that's prevention. You keep low GKI, it's going to be hard to get cancer, especially if what you're eating is nutritionally balanced. Macro and micro nutrition. So if that happens to be a vegan guy, a carnivore guy, a pescatarian guy, a Paleolithic guy, I don't care. Whatever they're doing to get that ratio down is probably going to be healthier than not getting it down.
Do you recommend fasting to fight cancer? And if so, what forms of fasting do you recommend?
If you can do it, it's not easy. Okay.
Right.
Look it'll wipe that smile right off your face. I can tell you that right now. Nobody's smiling after a 1 week of water-only fasting. We have some of our students sometimes used to be every day, big smiles on their face. They come in, they love life, they love everything. And then when they try to fast for several days, they sit with a moping-looking face. Yeah. I mean, it's not a friendly-looking face. So nobody's smiling and saying, "Oh, how great it is. I haven't eaten anything for 25 days. Look at how great I feel." No. It's a...
Je bespaart nog wel €75 aan stroomkosten per jaar door je oude wasmachine te vervangen met een nieuwe energiezuinige. En met Coolblue Energie krijg je er ook nog eens korting op. Dat is dus dubbel besparen. Wil je meer weten over energie besparen? Neem dan een kijkje op coolblue.nl/energie.
Skip het drama. En ga van het vliegveld naar huis met Flipco. Geen drama, alleen maar suave. Wanneer je van het vliegveld naar huis gaat met de Flipco shuttlebussen.
Let's go with Flipco.
It should be brought in. You can dovetail it to whatever religion you happen to be, give it up for the greater glory of God or something like this. Whatever can be dovetailed to help you do that. But I think it's easier if you go on a low carb diet for several weeks, get a low GKI, and then jump into a water only fast. It makes it the jump is not so dramatic than if you go 100%. Cold turkey in this whole thing.
Yes.
Yep.
So, but then again, those are the strategies that folks can use if they're really seriously interested in doing this for the betterment of their health. We don't use any drugs except the ones that are going to kill cancer cells. Mm-hmm. So, and the drugs that we use, I said, we use at low doses, and that's what the dosage timing and scheduling part of the press pulse concept. We're not there yet in perfecting the strategies for what dosage, timing, and scheduling you can use some of these drugs that will target glutamine. It's easier to target glucose with diet and lifestyle, but glutamine is a little bit more difficult. Unless you're doing a pretty good vigorous exercise, you can lower glutamine. But I don't know if it's lowered to the point where the tumor cell would be eliminated. That's why we use a little bit of a drug to push those over the threshold and kill them. And you don't want to ever use any kind of a drug that has a remote chance of harming a person. That tells you you're not doing it right. Okay, so all these terrible toxic effects you see the poor cancer patients, this is not right. This is wrong. This speaks to a profound lack of knowledge on the biology of the disease they're treating, because you can kill cancer without having to do any of this stuff. It's just that it's not known to the majority of people, or the oncology field, or the National Institutes of Health. So it's just a wall of, and then when you talk to those guys about it, oh, I don't know, hasn't been tested, oh, no clinical trials. And there's always a non-scientific argument for why it won't work. It's not like, oh, did you see the science? No, but it won't work. And it's like, give me a break. It's anyway, it'll be the future. You know why? Because the people want to live.
Yes.
There's a compliant population that want to do this.
I just wanted to ask about the macronutrients. We're talking about that, the macro and the micronutrients. We're in carnivore lifestyle, have been doing this for 3 years, 5 years, 6 years. There's no carbohydrates coming in. And I just was curious, what are your thoughts on zero carb coming in?
I don't know what to say about that. As I said, I'm not into that kind of research.
Sure.
Okay. Our adversary is a dysregulated tumor cell.
Yep.
And our goal is to kill it, okay, without causing collateral damage. And also, whatever you do to maintain the health and vitality of your body. My colleagues take extensive blood work on the patients. So, and you can look at all the salts and the micronutrients in the blood, and you can look at all this. So you got to keep that patient in the zone of health. And whatever that does, as I said, if he needs to eat a head of broccoli to do that, let him eat it. This other guy wants to bite into a chunk of ribeye, let him do it. The issue here is you got to maintain metabolic homeostasis, and one shoe does not fit all. One food.
Absolutely.
This might not be appropriate for the other guy. That's why we try to use very careful blood work and GKI and these kinds of things to know when a person is in a really healthy zone. They have low carb, high ketones, and they're overall well balanced with respect to macro and micronutrients. Humans are supremely qualified to eat almost anything, and but that's a personal preference. If some guy can't eat a plant, I mean that's his personal preference, and the other guy, he can only eat plants, and I don't know, whatever it is. One of the problems we have, though, is even though we have this knowledge base and we know what to do and how pretty much to do it, there's nowhere for anybody to go. Where do you go to get this? Okay,
Absolutely.
So I'm saying all this stuff, and I get the most negative comment I get back is that people tell me, "Oh, you just told us all this great stuff," but then when I go to my oncologist, I get slapped down. He never heard of it. Says sugars doesn't have anything to do with cancer.
Right.
So, and then the people keep pushing him, and then he gets angry and throws them out of the office. And that's not the way things should be done.
Yes.
So right now we have the strategy, we have the plan, we have the knowledge. We just don't have the clinics to do that. We need to train physicians to know how to use the power of metabolic oncology to manage cancer. And it does involve understanding the value of macro and micronutrients in diets. You don't want to put a patient out of balance metabolically. You want to be in metabolic homeostasis, which means that all systems are working together in a whole of the whole body. And we need to keep that body healthy as we slowly degrade the tumor. So you have to have a person that's your caregiver that understands this and can administer drugs at the right dosage, timing, and scheduling, and knowing the feedback, looking at non-invasive imaging analysis. How did the patient feel? Look at the blood work and all this, and gradually move this patient from a state of unhealth to a state of health. And that's all spelled out, outlined, the framework in the press pulse therapy that we published already, open access. In it was Nutrition and Metabolism, I think. It's out there. People can look on the web. It's there. They can follow it. But it doesn't tell you exactly how much drug, embendazole or fenbendazole, should I take when I'm in this GKI. You got to have somebody there that's helping. And these folks can interact with their physician over the net. They can look at some of these new blood glucose monitors like a Free Libra and these other kinds of things can be fed into a computer, and you can be knowing right away if you're in the zone or not in the zone. And we developed the GKI because monitoring blood sugar and ketones independently of each other can create a great deal of anxiety in the cancer patient. Blood sugar is very volatile. And you're dividing it by a certain level of ketones in the blood. So the volatility is not so acute. You get into an argument with somebody, your stress level goes up and blood sugar naturally goes up.
Yes.
Okay, but if you have a significant level of ketones buffering that, then the overall stress to the body is not so great. So we learned to do that. That's why we built the GKI in the first place. So and it's widely used now. I'm even shocked at how many people are using it for all kinds of stuff. Cancer.
In our community, GKI is where it's at. We, Keto Mojo is always at the conferences, and it's made big difference for people.
Yeah, well, we developed that, and everybody says, "Oh, I should have made $1 million on the thing." You can't patent. Now, we couldn't patent the damn thing. You can't patent a formula. So everybody, we get our research here at Boston College from private foundations and philanthropy. So, but I wish I had that thing patented. I could run my lab on the money that I made from the GKI, but I'm not making a nickel on that thing. But I'm so happy that I'm so happy that so many people are using it to improve their health.
That's right.
That's also worth something. It's just not financial worth. It's just, mental.
We get it. We're trying to figure out how to make a buck off a carnivore, and it's not there. I understand.
It's the entrepreneur that will come in that knows how to put all this together in a kind of a clinic that can, you would charge patients for the treatment process. So the revenue generation will probably come from the scheduling and timing of what you're doing, rather than from charging some guy $300,000 for a CAR-T immunotherapy, or that'll blow his liver or kidneys out at the same time trying to kill his cancer. So so it'll change because people want this. It's just that we need to train individuals and put the education out there, and eventually it'll slowly start to change.
Je gaat vaker weg dan je denkt. Dus sluit je de doorlopende reisverzekering van Interpolis af.
We have had several clients that came in with cancer, and as they followed the fasting and carnivore, their cancer started to either go in remission or gone away. One was specific that really brings up, he had a tumor in his brain, and that actually went away within, I think, a month of doing this lifestyle, which is incredible. But what we're seeing these results. Now, we don't know how it works, but now that you're explaining it, that's what I want to hear.
You're causing a radical change in the way the body is working. And as I said, the tumor cells lack flexibility. So they often have great difficulty adapting to the new metabolic environment of the body. And sometimes you can kill them. Yeah, I've seen it. Maggie and Brad Jones on their documentary, The Cancer Revolution, are collecting all of these people who have undergone radical remissions in cancer based on radical changes in diet and lifestyle. So a lot of them getting low GKI values. A lot of them, I'm even shocked at how you're right. I without even targeting glutamine, I've seen some dramatic changes in people's cancers. I just think we can probably accelerate the destruction of these tumors if we target glutamine at the same time. But I do see, and people, I don't call our work curing cancer at all. I call it managing cancer. If you can manage the disease or the disorder and improve overall survival and quality of life, I think that's important. And I think we've gravitated too much toward this idea that we're going to cure cancer. And, oh, you're going to cure cancer. What the hell's wrong with managing it?
Right.
You know, you're not, in other words, you're living with it. Whether you're cured or not, nobody knows. If you got cancer, you're a young guy, you get cancer, and you live to be 98 years old, and you die from a heart attack, and the cancer never came. Okay, then your survivors can say that guy was cured from cancer because he never came back. But I don't know. I mean, I'm into the managing it, right? That's our thing. We want to manage cancer and take fear away from people and allow them to know that they have a fighting chance to manage this disease, this disorder, with some new ideas that will require some personal discipline and self-sacrifice. But at the same time, there's outcomes that are seen shockingly to me, because I work with mice predominantly, and we have never cured a mouse with the natural cancers that we have. These mice cancers will kill them in 15, 20 days. Humans, we have a lot more time to go after those tumor cells. And the mice cancers are all of one cell type of the most aggressive. Humans have some kinds slower growing neoplastic cells next to mesenchymal stem cell neoplastic. Sometimes there's a hodgepodge of different kinds of neoplastic cells in a person's tumor, all of which may use a little bit of glucose more than glutamine or vice versa. But together, those two, whatever the cancer is in that tumor, it's dependent on that, those two fuels. And we have a lot more time to work on it. The patient, from the time of diagnosis to death, is not 15 days, like it is in the mouse. So when you hear people say, oh, we cure mice all the time, no, we don't. If you're using natural tumors in the mouse, we have been trying for 30 years and we haven't got a cure on these damn mice. Now, we've kept them alive massively longer than would have been expected, all right? Which then translates into years of people. So, and I consider that success. So let's say we're on the path for cancer management. If someone were to be cured, oh, my hat's off to that guy. But I can't say that. Don't ever say Seyfried says we can cure cancer with diet. I don't. Okay, but we can manage. I think we have a better chance of managing it. So, and that's, I think, is important. At least it puts us on the path to eventual potential resolution or long-term management. But where we are right now, it's an absolute disaster, torturing, poisoning these people, and having 1,700 people a day dying from this cancer is nuts. This should not happen.
I wanted to ask something about the environmental cause of cancer, though. So far, we've been talking about metabolic, but isn't there an environmental cause?
I broke all that down in several of my papers. So everything comes through damage to the mitochondrion in a particular cell in a particular organ at some point in your life. But then you have to say what's causing the damage in the first place. And that's your environment comes in. So you have exposure to chemical carcinogens. They call those chemicals carcinogens because they link to cancer. Okay, but how do they cause cancer? And the answer is they enter into your body, they get into your cells, and they get into the mitochondria and disrupt energy metabolism, causing the formation of ROS, which are reactive oxygen species. And ROS are carcinogenic and mutagenic. So the mutations that we see in the cancer cells are coming as downstream effects of, say, a carcinogen. How about radiation? People fear radiation because it damages mitochondria, leading to ROS that cause mutations. But that's an environmental cause, exposure to radiation. How about intermittent hypoxia? Sometimes sleep apnea. If a person might be obese and have sleep apnea, intermittent disruption of oxygen into our body can damage mitochondria in a particular population of cells. Okay. How about oncogenic viruses? All right, like papillomavirus, hepatitis. These are environmental approaches, they get into the cells and they damage the mitochondria, putting them on the path for fermentation metabolism, at the same time producing reactive oxygen species. We broke this whole thing down. We know that you can't get cancer without damage to the mitochondria, and damage to the mitochondria can be from an inherited risk factor like a BRCA1 or a Li-Fraumeni p53 mutation, or it can come from carcinogens, or it can come from sleep apnea, or it can come from systemic inflammation linked to type 2 diabetes. All of these things are from the environment and maybe some genetic risk factor. But whatever it is, it's all impinging on the ability of that organelle to produce energy through oxidative phosphorylation. And when that is chronically disrupted, the cell ferments to compensate. If it happens too acutely, the cell will die through an apoptotic mechanism and never become a cancer. So you got to not kill you can't kill the cell too acutely. It's got to be a chronic damage to its energy efficiency, leading to a transition to fermentation driven by glucose and glutamine. And they're falling back on pathways that existed before oxygen came into the atmosphere 2.5 billion years ago.
Fascinating.
Right? And it's supported by all the science, too, for those that want to read about it all. So as long as you know this kind of stuff. So it's a biological. If you understand biology, evolutionary biology, biochemistry, genetics, you can put it all together and you come up with this plan.
Beautiful.
It's beautiful. It even sometimes shocks me, but it works.
There's a basic vocabulary that I think people can learn a lot of by, just the resources that are out there. And then you can go that next level with your provider because you are speaking the same language. Right.
But when you go to the provider and they say glucose has nothing to do with cancer and diet and nutrition are irrelevant, then you should walk out because that guy knows nothing. But that's so many. I hate to say it. It's just so many physicians. I feel bad for them. I feel, why are they not trained in medical school they're trained that cancer is a genetic disease. So all this stuff is what they're trained to do because it's a genetic disease and we have to do this kind of stuff. But it's not a genetic disease. It's a mitochondrial metabolic disorder. And once you understand that, the playing field changes completely. So the strategies become very, very different and more effective and less toxic. So that's the future. How long it's going to take, I have no idea. But in our papers, we do a deep dive on a lot of this stuff. So, he didn't say this, he didn't say that, he didn't say this. Well, read the damn papers. It's in there.
Right.
So, and it's open access. So folks, just put my name, Google, what are Seyfried's publications? Oh, look at all that. Start reading them. Then you become enlightened. And then you know what to do and how to do it. But we need healthcare professionals that help us.
Yes,
If I had a tumor, I wrote all this stuff, I would still seek consultation with some of my colleagues.
Yeah.
It's just a way of comforting, knowing that, we're doing the right thing and, maybe we should tweak it this way or that way. But the bottom line is you like to speak to somebody, especially for the layperson that might not have the depth of understanding about all this stuff. They want to talk to a healthcare provider that actually understands the fundamental issues and can discuss that with them and work together as a team to manage your problem. As I said, our research continues on the goodwill of philanthropy and private foundations. And as long as we're continuing to do this research and writing the protocols, all of this will happen. It's a guarantee. It's going to happen. I just don't know when the field is going to do the big flip, and it's not going to flip anytime soon, considering what has to happen.
I have linked all of Professor Seyfried's recommended resource down below in the description box. If you would like to submit your question for Professor Thomas Seyfried, he will be visiting the SBG community to answer member questions. For more details and how to attend and submit your question, just go to the URL shown on the screen, sbgmeetup.com, or check out the links down below in the description box. I know that many of you guys want to improve your sleep and sleep quality. This is where I recommend using blue blockers like these ones to protect our eyes from harsh blue light. Blue light is found in all of our devices, including our TVs, iPads, laptops, phones. So if you are constantly in front of screens and not sleeping well at night, wearing blue blockers can really help make a difference. I have these two from Bond Charge. Both are in the design called Magnum. This yellow one is medium protection and this red one is maximum protection. I always wear these red ones the moment it starts getting dark outside here in Seattle and while I'm doing doing meetings, filming, editing, working on my laptop, they're always on to protect my eyes from the blue light. Wearing blue blockers also helps your body produce more melatonin so that you can fall asleep and stay asleep. And for those who are into biohacking, I also have been loving Bon Charge's sauna blanket. It's basically a 360 completely wrap around you type of blanket, and the red light therapy is inside the entire sauna blanket. It's super easy to use. You just plug it in, wrap yourself in this blanket, and reap all of the benefits of red light therapy. If you'd like to check out all of the favorites that I've mentioned, I'll make sure to link them down below in the description box alongside my discount code. I'll see you in my next video. SPG out.